Hello everyone. The title of this video is Solve Radical Equations. In this video, I'm going to be working on exercises and examples taken directly from a free online textbook at openstax.org, and this is their Intermediate Algebra 2nd edition text. And I'll be working on exercises under the heading Solve Radical Equations. And I'm only going to be working on the even numbered exercises, because if you see the odd numbered exercises, you can click on the link and it'll show you the solutions. It'll take you to the solution. So I'm only going to be working on the questions that don't have solutions listed. So that'll be, and I'll have timestamps for each question, each example in the description of the video. Alright, so example 1 will be number 288, example 2 will be number 290, example 3 will be number 292, and so on, all the way down until we get to number 322. Alright, I'm going to do all the even numbered problems up to 322. And again, if you want to use the timestamps to navigate the video, go to a specific problem you want to see, please do. And one of the requests I would have of you is that when I start a new question, pause the video and try to do it yourself first, and then see how I did it and compare. Right, because if you're just watching me do these things and not practicing yourself, chances are you're not learning all that much. Alright, so the first question I'm going to do is exercise 288. Got that written out here. So you see example 1, then underneath I have written number 288. Okay, so we're solving what are called radical equations. The reason they're called radical equations is because we have an expression with a variable in a radical symbol right inside a root. Alright, so I'm going to write off to the side here the steps I'm going to follow in every single one of these exercises. Alright, so the first step is going to be to isolate a radical. Isolate radical, which for this first example that is already done. You see the radical is already by itself, the radical isolate radical term, I should say. See, the radical term on the left is already by itself. There's nothing added to it, nothing subtracted from it. The radical term is alone, and then everything else on the other side. Alright, then we're going to raise both sides to a power. Raise both sides to a power, to an exponent, to, quote unquote here, undo the radical symbol. I'll just say to undo the radical. Alright, so basically we're using the following property. If you have the nth root of some number, right, and you raise both sides to the nth power, right, well, not both sides, there's no sides here, but if you take an nth root and raise it to the nth power, that'll undo the radical, and you'll be left with just the radicand a. Okay. Alright. So we're going to use that property quite often in this video. Then next, so let's do that here before I move on to the next step. So I'm going to take the left side, the square root of 4x minus 3, and to undo the radical, right, this is a square root, so I'm going to raise both sides to the second power, right, and do the same thing with the other side, right, 7 squared. And that will undo this radical, and I'll be left with the radicand, 4x minus 3 on the left, and 7 squared, 7 times 7 is 49 on the right. Then I'm going to solve the resulting equation. All right. So we have here 4x minus 3 is equal to 49. So adding 3 to both sides, that would give me 4x equals 52. And then dividing both sides by 4, I get x must be equal to 13. Right? 4 times 13 is 52. And then finally, check your solutions, right? This is a possible solution to the equation. Always check, right? Check solutions always back in the original equation, right? The way it originally looked, the way we were given it. Okay, so let me do that here. So we have, I'm going to check x equals 13 back in the original. So we have the square root of 4 times 13 minus 3. Is that equal to positive 7? Well, 4 times 13 is 52, minus 3 is 49, so we have the square root of 49 equals 7. And then don't forget, when you see this symbol, right, when you see an even root symbol, square root, fourth root, sixth root, it's asking you, it's telling you to give me, give them the positive square root. Because yeah, negative 7 squared is also 49, but that's not what the symbol is asking for. And I've said this in many other videos prior to this. So this is positive 7 on the left equals positive 7 on the right. This works. This is true. This is true. So the only valid solution here is 13. But you gotta check it though. You gotta check it, especially when there are even roots, square roots, fourth roots, etc. Especially when there are even roots in the equation. All right. Now odd roots, you can take an odd root of any number, and when you take the odd root of a real number, you're gonna, there's no confusion there. You get one number back. There's no positive odd root or negative odd root like there is with some even roots. So I would say for odd root problems, if you know you did everything correct, you're probably right and wouldn't have to check, but I'm still going to check. Okay, still going to check. Okay, great. And that's it. I'm going to follow these same steps for every single question. Okay, next question. All right, number 2. Now this is corresponding to number 290 in the text. The square root of 3y minus 4 equals negative 2. All right, I'm going to tell you right now that this has no solution. This can't happen. As if you recall, I just said it a second ago, this side here is the positive square root, or the non-negative square root, right? That symbol means give me the non-negative square root. So this side is a non-negative number based on the symbol, right? And this side is a negative number. negative 2. So what this is saying is that some non-negative number is equal to a negative number. This can't happen. Right? A non-negative number can never be equal to a negative number, meaning that this equation has no solution. Alright, so we'll eventually see that, if for some reason you don't recognize that, hey, this can't happen, let's try going through the steps and, we'll see that this equation has no solution. So I'm taking the left side, right? First of all, the radical term, the radical is by itself, right? A radical is isolated. Step 1, right? And then I'm going to raise both sides to the second power because this is a square root. So we have on the other side negative 2 to the second. That'll undo the radical. We have 3y minus 4 on the left. And then negative 2 squared is positive 4 on the right. And then you're seeing that y equals, 8 divided by 3, 8/3. Alright, 8/3. But let's check that. Alright, I'm not going to say that that's the solution until I check it back in the original equation. Alright, so checking this, we have the square root of 3 times 8/3, right? 8/3 for y, minus 4. Is this equal to negative 2? Well, 3 times 8/3 would be 8, minus 4 would be 4, so we have the square root of 4 equals negative 2. And again, I know you're thinking, hey, negative 2 squared is positive 4. This is true, but remember, when you see an even root symbol, that symbol is asking you for the non-negative root. The only time they're asking you for a negative root is if there's a minus sign in front of the symbol. So this is actually positive 2 on the left, and then we get positive 2 equals negative 2. All right, this is a false statement. So this is no good. All right, we would say that 8/3 is no good. It doesn't satisfy the equation. Right, remember they call that an extraneous solution. Right, extraneous solution. And if you, go through trying to solve an equation and all the solutions you found don't actually work, that means that the equation has no solution. All right, so this equation has no solution. And that's it. The solution set would be the empty set. If you were writing it that way as well, you can. Okay, great. But yeah, always check your solutions though, back in the original. Alright, next question. This is example 3, corresponding to exercise 292 in the text. Alright, so now I have a radical equation, but this time we have a cube root, right, an odd root. Alright, first step is isolate the radical. Well, already you can see this radical, this cube root, is already by itself on the left side. So then I raise both sides to a power. Right? Now this time, because it's the cube root, I'm going to raise both sides to the third power to undo that radical symbol. Raise both sides to the third power. Alright, so here the radical symbol is removed, and you're left with just the radicand 4x minus 1. and then 3 to the third power is 27. 3 times 3 times 3. Then we would add 1 to get 28, divide by 4. 28 divided by 4 is 7. Right, and then check. If you plugged in 7, I'm just going to say it out loud now. 4 times 7 is 28, minus 1 is 27, and the cube root of 27 is 3. You'd have 3 equals 3. This works. 7 is a good solution to this equation. All right, and I'll put a check mark next to it, letting you know that I checked it back in the original equation. Okay? Wonderful. All right. Next question, number 4, is exercise 294 in the text. All right. So the first step isn't done here. All right. See this radical term, the square root of 2n minus 1. This is not alone. All right. You see there's a minus 3 also on the same side. I want to get rid of that. All right. So I want to isolate the radical. All right, get the radical alone. So that'll involve, adding 3. So now I have the square root of 2n minus 1 equals, positive 3. All right, now that the radical is isolated, we raise both sides to a power to undo the radical. I'll just do it here. Now this is a square root, so I'm going to raise both sides to the second power to undo it. I'll be left with 2n minus 1 on the left equals, 3 squared is 9 on the right. Then I would add 1 to get 10, divide by 2 to get n alone. 10 divided by 2 is 5. Alright, so this is a possible solution, right? N equals 5. Let's check it out. When I put in 5 for n, 2 times 5 is 10, minus 1 is 9. The square root of 9, right, the non-negative square root of 9 is 3, and 3 minus 3 is indeed 0. You'd have 0 equals 0. This works. Wonderful. And again, don't forget to check. Alright, so the solution's 5. Great. Next question. In fact, the next page is very similar. The next few questions, where the radical isn't isolated, right? I have to isolate the radical first. So number 5 corresponds to number 296 in the text. So once again, I have this radical term, the square root of 12u plus 1, that I want to isolate, right? So get rid of the minus 11 by adding 11. So that'll give me the square root of 12u plus 1 equals positive 11, right? And now I isolated the radical. Now I wish to undo the radical, raising both sides to the same power, and that would be to the second power since this was a square root. So now on the left side I have the radicand 12u plus 1 equals, and then the right side, 11 squared, 11 times 11 is 121. Then subtract 1 gives me 120. Dividing by 12 to get u alone would be 10. Right? 120 divided by 12 is 10. Alright, and if you check this, plug in 10. 12 times 10 is 120, plus 1 is 121. The square root of 121 is 11. Minus 11 would be, you'd have 0 equals 0. This works. Alright, so 10 is a good solution. Great. Alright, question 6, which is number 298 in the text. So once again, I have this radical I want to isolate, get alone. So that'll involve the subtraction of 4. I subtract 4 from both sides. So we have the square root of 6n plus 1 equals, 8 minus 4 is 4. Now I undo the radical, right? Raise both sides to the same power. This would be to the second power again, right? That's a square root. Left side now I have 6n plus 1. And the right side, 4 squared is 16. Alright, then I subtract 1 to get 15. And then divide by 6. So n equals 15 sixths, which would be 5 halves when reduced, right? 2.5. Now let's plug it in, right? Check it out back in the original. 6 times 5 halves would be 15, plus 1 would be 16. The square root of 16 is 4, and then 4 plus 4 is 8. That definitely works. You'd have 8 equals 8 on both sides. So great. I'll circle it. 5 halves or 2.5 or 2.5, whatever you want to write, works out. Is a solution. Great. All right, next question. Very similar. So question 7. Got another. This is number 300 in the text. Same steps. I wish to isolate this radical first. So I'm going to subtract 5. So I have the square root of 5v minus 2 equals, and when I subtract 5, 0 minus 5 is, negative 5. Now, kind of like an earlier example, I believe it was example 2, this can't happen. Remember, this square root of something with this square root symbol, that can't be negative. So on the left side, I have something that can't be negative equal to something that is negative on the right side. So I'm going to write this right now. I'm going to tell you this has no solution. Now I'll go through the steps, but I'm hoping that at some point you get to the point where, you recognize that the equation has no solution right away. Alright, so let's go through the motions here and follow the steps. Again, it's a square root, so I'll raise both sides to the second power. Left side would be 5v minus 2. The right side would be positive 25. Then we get v equals 27 fifths. Right, 27 fifths. Now if you were to plug this in, 5 times 27 fifths would be 27, minus 2 would be 25. The square root of 25 they're asking for here is the positive one, positive 5. And then you'd be saying 5 plus 5 equals 0. 10 equals 0. 10 equals 0. That is not true. So I'm going to put a big X through this. That is not a solution. It's an extraneous solution. And all the solutions I found didn't work. So the equation has no solution. Alright? Great. Alright, next question. Now this one's a little different. Because now, so far in all the equations in exercises 1 through 7, the variable that we were trying to solve for was inside the radical, but nowhere outside the radical. Well, here in number 8, which is exercise 302 from the text, see the variable inside the radical, v minus 10 here, but there's also that same variable outside the radical, right on the other side here with the v. But still the steps are the same, right? The steps are no different. So first I wish to isolate this square root, right? Isolate the radical. So first I would subtract 10. Right? So we have the square root of v minus 10 equals v minus 10. And then I undo the radical by squaring both sides. Alright, this one you got to be a little careful. Alright, this side, the radical is just undone, and you have v minus 10. But on this side, remember what it means to square something with multiple terms. Alright, this means you're doing v minus 10 times v minus 10. So I'm going to be doing foiling, lots of distributing. So that'd be v squared minus 20v plus 100. Right. And what I have here now is a quadratic equation. So I'm going to solve this like I've solved, most other quadratic equations. I take everything to one side and get 0 on the other. So I'll subtract v and add 10. So I have v squared. Then, if I subtract v, we'll have minus 21v. And then if I add 10, get plus 110. And this is actually, I can see it right now, easily factorable. This would factor to v minus 10 times v minus 11. Alright, that'd be v squared and then minus 10v minus 11v for minus 21v and then plus 110. So the possible solutions here are v equals positive 10 or v equals positive 11. Now, don't forget to check these. Alright, if v were 10, you'd have, 10 minus 10 is 0. So then the square root of 0 is 0. And 0 plus 10 is 10. So you'd have 10 on the left side. And again, v is 10, you'd have 10 on the right side. So v equals 10 works. You end up with 10 equals 10 in the equation. So I'm going to circle that, right? 10 is a good solution. Let's check v equals 11. If I put in 11 for v, 11 minus 10 is 1. The square root of 1 is 1. 1 plus 10 is 11. So I'd have 11 on the left side, and v equals 11, right? But 11 on the right side. I'd have 11 equals 11, which is true. So both of these are solutions, not just one. Right? Both of them work. So positive 10, positive 11, both make this true. Fantastic. All right. Next question. Very similar to this last one. All right, so question 9. Number 304 in the text. We have the square root of s minus 8 equals s minus 8. Alright, so the radical is already isolated. So I would just, undo the radical, square both sides. So I'll just write that, just write square both sides, raise both sides to the second power. Now the left side, the radical will be undone. You have s minus 8. The right side, you'll have s minus 8 squared. So s minus 8 times s minus 8, that'd be s squared minus 16s plus 64. Alright, hopefully you can follow that. And then just as before with any quadratic here, I'm going to subtract everything, take everything to one side, 0 on the other, and then you could use the quadratic formula or solve by factoring, whatever. So if I subtract s, we'll have s squared minus 17s, and then adding 8 will give me plus 72, and I can see how this will factor. All right, again, you could use the quadratic formula if you want to get the solutions to this. But this will factor to s minus 8 times s minus 9. Right. And you can check that if you wish. So the possible solutions are s equals positive 8 and positive 9. Right? All right, now check them. When s equals 8, can you see that we'd get 0 equals 0? So this works. And when s equals 9, hopefully you can see that you'd get 1 equals 1. The square root of 1 equals 1, 1 equals 1. Also true. All right, so both work. Two solutions, s equals 8 and s equals 9. Fantastic. All right. Okay. All right, so now we're back into a cube root problem. So the radical, number 10, which is exercise 306 in the text, got a cube root all by itself, right? It's isolated. The radical term is isolated, equals 5. And undo that cube root. Or raise both sides to the third power this time. Okay. Left side, no problem. It's just 11x plus 4. 5 to the third power. 5 times 5 times 5 is 125. And then I hope you can eventually see that x must be 11. Right? I'd subtract 4 to get 121, then divide by 11. Right? And then check it. Right? When x is 11, 11 times 11 is 121. Plus 4 is 125, and the cube root of 125 is 5. You get 5 equals 5. So this indeed satisfies the equation. Great. All right, number 11, which is exercise 308 in the text. All right, so here, the first step needs to be done. This radical term with the cube root needs to be isolated. So first I shall add 1. So we have a cube root of 9x minus 1 equals, negative 4. Right, now this can happen, right? Remember, when we had square root equal to a negative, that was bad. But a cube root, an odd root, can be negative, right? So this might have a solution. All right, so now I'm going to raise both sides to the third power, right, to undo the cube root. And that leaves me with 9x minus 1 on the left. And then negative 4 to the third power would be negative 64. All right, then we add 1 to get negative 63. Divide by 9, x would be negative 7. And then don't forget to check it. All right, well, 9 times negative 7 would be negative 63, and then minus 1 would be negative 64. The cube root of negative 64 would be negative 4, minus 1 would be negative 5. You'd have negative 5 equals negative 5. This works. Wonderful. All right. All right, so now in number 12, we start getting to some exercises where the radical isn't written with a radical symbol. Instead, it's written with a fraction power. But hopefully you recall that an nth root, right? Remember an nth root, a radical, was the same as taking the radicand and raising it to the 1 over n power. Right, remember, a radical was the same as a fraction power with a numerator of 1. Right. So this is no different. Right, this is the same thing as the square root of 3x minus 2 and then plus 1. equals 6. And if you want to write it that way, that's totally fine. There's nothing wrong with that at all. Okay, so yeah, I'll leave it this way in the radical form. Again, you can work with either one. Isolate the radical. So we have the square root of 3x minus 2 equals 5, right, after subtracting the 1. This is a square root, so then I square both sides. We'd have 3x minus 2 must be equal to 5 squared, which is 25. And then adding 2, dividing by 3, we'd get x has to be 9. Right, x has to be 9. And then plugging this back in to, again, either one of these equations, because they are the same thing, right? These originals. 3 times 9 is 27, minus 2 is 25. 25 to the 1/2 power, that's the same as the square root of 25, which is 5. 5 plus 1 is 6. You end up with 6 equals 6. This is good. All right, so the solution is 9. Great. All right, next question, very similar. Just again, remember this relationship between radicals and fractional powers, and it should make it pretty easy. So question 13 is exercise 312 in the text. We have 12x minus 5, to the 1/3 power plus 8 equals 3. Once again, I'll write it in radical form if you're more comfortable with that. This is the same thing as the cube root, right? It's the 1/3 power. The cube root of 12x minus 5, and then plus 8 equals 3. And then I isolate the radical, subtract 8, and we have the cube root of 12x minus 5 equals, 3 minus 8 is negative 5. Then I would raise both sides to the 3rd power to undo the radical. We have 12x minus 5 on the left equals, and then negative 5 to the 3rd power would be negative 125. Alright, then add 5 for negative 120, divide by 12 for x equals negative 10. Alright, x equals negative 10. And then check it, again, either here or here, they're the same equation. 12 times negative 10 is negative 120, minus 5 is negative 125. The cube root of negative 125 is negative 5. Negative 5 plus 8 is indeed 3. You'd have 3 equals 3. So negative 10 works. Negative 10 works. Wonderful. All right, very similar for number 14. Only the power is, the 1/4 power. And this is exercise 314 in the text. So once again, you don't have to do this, but I am, right, just because we're comfortable with radicals right now. 5x minus 4 to the 1/4 power is the 4th root of 5x minus 4. Same thing. And then plus 7 equals 9. Isolate the radical, right? So subtract 7. You have the 4th root of 5x minus 4 equals 2. Then I would raise both sides to the 4th power. Right? Let me actually write that this time. Right. So raise both sides to the 4th power to undo that radical. So on the left side I have the 5x minus 4, and then the right side, 2 to the 4th power is 16. And then I would add 4, which is 20, and then divide by 5, we get x equals 4. Alright, and then check it. When I plug in 4 for x, 5 times 4 is 20, minus 4 is 16. The 4th root of 16 is positive 2. Remember, that's the positive 4th root, not the negative one. And then 2 plus 7 is 9. You'd end up with 9 equals 9. This works. Right? This is the valid solution. X equals 4. Alright, great. Alright, so that seems to do it for the exercises with fraction powers. Just remember, you can always change them to radical equations. Alright, so now we're getting back into those equations where there's a variable in the radical and that same variable outside the radical. Alright, but still the steps don't change. Alright, the steps are no different. So number 15, which is exercise 316 in the text, I want to isolate the radical first. So I want to get that square root of y plus 4 on its own side, and then all the other stuff to the other side. So I would add y, so give me positive y, and then subtract 2. So we have the square root of y plus 4 equals y minus 2. Now the radical is isolated. We undo it. Right, raise both sides to the second power. Alright, so on the left side we have y plus 4. On the right side, remember, you don't distribute the powers. This is y minus 2 times y minus 2 again, and then you would FOIL. This would be y squared minus 4y plus 4. So be careful with that when there are multiple terms in an expression being squared. And this is just a quadratic equation. Right? I'll just subtract y, subtract 4. We got 0 on the left equals y squared, minus 5y. And then subtracting 4, gets rid of the 4's. And y squared minus 5y, they have a common factor of y. This is just y times y minus 5. Alright, so taking this up here. Then the possible solutions then are y equals 0 or y equals positive 5. Alright, just don't forget to check them. Alright, y equals 0. You'd have the square root of 4, which is 2, minus 0, which is still 2, plus 2, which is 4. You'd have 4 equals 0. You'd have 4 equals 0. So that's an extraneous solution. That is no good. Right. So y equals 0 doesn't work. Y equals 5, on the other hand, you'd have the square root of 9, which is 3, minus 5, which is negative 2, plus 2, which is indeed 0. So y equals 5 is the only good solution here. Right, so 0 doesn't work. 0 is extraneous. 5 does work. It does make the original statement true. Just don't forget to check. Okay. Number 16, which is exercise 318. So once again, I wish to isolate the radical. So I want that square root of w plus 25 by itself. And in order to do that, I would add w. Right? So on the other side, we'd have w and then still the minus 5 there. Alright, then we square both sides. It's another square root. So the left side is w plus 25. The right side would be w squared minus 10w plus 25. Right? If you take w minus 5 times w minus 5. Alright, and again the 25's will go away. So I have 0 equals w squared minus 11w, which is w times w minus 11. So the possible solutions are w equals 0 or positive 11. Alright, now let's check them. Well, 0 doesn't work. If I put in 0, we have the square root of 25, which is 5, minus 0 is 5. We have 5 on the left, negative 5 on the right. So that doesn't work. Alright, get rid of it. It's extraneous. Now w equals 11 does work. you'd have the square root of 36, which is 6, minus 11 would be negative 5. You'd have negative 5 equals negative 5, and that's the only one that works. Right? So 0, no good, 11 is good. Okay, great. Alright, then I have one final example, well, one final page of questions. So number 17, which is exercise 320 in the text. So again, I want to isolate the radical term. So we have 2 times the square root of 5x plus 1, and I would be adding 8. Now, normally I wouldn't do this. You would just square both sides, and this becomes 4 times the quantity 5x plus 1. But because 2 goes into 8 evenly, and I won't be dealing with any fractions and whatnot, I'm going to divide both sides by 2 and get just the radical by itself, not just the radical term. So the square root of 5x plus 1 equals, 8 divided by 2 is 4. Then square both sides. 5x plus 1 equals 16, right? 4 squared is 16. Then x must be 3, right? Subtract 1 to get 15, divide by 5. X must be positive 3. Alright, and don't forget to check. Alright. 5 times 3 is 15, plus 1 is 16. The square root of 16 is 4. 2 times 4 is 8. 8 minus 8 is 0. You would end up with 0 equals 0, a true statement. Right? So 3 is a valid solution. Wonderful. And then 18 is very similar, right? Just again, I'm trying to isolate the radical. So let's get this radical term on its own side. 3 times the square root of 7y plus 1 equals, I'd be adding the 10 to get 18 on the right. And then once again, normally I would square both sides here, get 9 times the quantity 7y plus 1 equals whatever 18 squared is. But because 3 goes into 18 nicely, I'm going to first, I'll get just the square root alone. Divide by 3. We have the square root of 7y plus 1 would be equal to 6, right? 18 divided by 3. Then I square both sides. You get 7y plus 1 on the left equals 36 on the right, right? 36 squared, right? Subtract 1 to get 35. Divide by 7 to get 5. Right? Y equals 5. And then, of course, check it. When y is 5, you got the square root of 36, which is 6. 3 times 6 is 18. 18 minus 10 is 8. You'd end up with 8 equals 8. This works. Wonderful. Alright, so that's it. Alright, following the same steps all the time when you see these radicals, square roots, cube roots, fourth roots in an equation. Isolate the radical. Raise both sides to some power, to get rid of that radical symbol. Solve the resulting equation, and then always, always, always check your solutions, back in the original equation to see if any of them are extraneous. And if all of them are extraneous, like you've seen in some of these, then there's no solution. Right. Okay, great. I'm hoping that watching me do these 18 examples helps you in some way when you're asked to solve radical equations on your own. And thank you very much for watching.